All right, welcome everybody. We're going to talk today about the normal distribution, our standard normal distribution, and then our applications of that standard normal distribution with our calculations on StatCrunch, primarily to compute those probabilities, that area under the curve. And so when we hear that standard normal distribution, that's our bell-shaped curve, but when we use z-scores, right? So let me start to share the screen. I'll share my document camera and we can have that quick discussion and then get right into some of our examples, right? So we'll do some examples later. But for now, when we're looking at our standard normal distribution, we're talking about that normal distribution being our bell-shaped curve. Okay. We have our number line here, and then our bell-shaped curve as best I can draw my rendition. Okay. And so with our normal distribution curve, we have kind of our peak occurring here in the middle. And so with the standard normal distribution, when we see that fact that it's standardized, that means our mean mu is equal to 0, and our standard deviation sigma is equal to 1. Commonly, we'll do this for a population in our references, okay? And so when we start to see this, right, we'll have our mean, that peak occurring in the middle, 0, and then we can start to organize, right, that standard deviation, that distribution, how spread out we are, one standard deviation above, one standard deviation below, two standard deviations below, two standard deviations above, so on. And we start to get into those references again where kind of out here in those tails, beyond two standard deviations, right, that will be considered unusual. We commonly expect values to be in this range, right, between -2 and +2. And so when it comes to that standard normal distribution, typically what we see here is that we're going to start to use those z-scores, right? So that's what we're standardizing. So because very few populations that we're going to work with have a mean of 0, standard deviation of exactly 1, but we can fit all of our normal distributions into this common shape. So standardizing, we start to do it in terms of z-scores, right? And that work we did back in chapter 3 with our measures of position in our data set, your particular data value minus the mean all over the standard deviation. And so when we start to see these values, that axis, we start to see our z-scores, okay? But traditionally, right, when we start to apply our normal distribution to more common and real life applications, right, we're not going to have that mean equal to 0, the standard deviation equal to 1. We'll have, again, my quick drawing of that normal distribution, that bell-shaped curve. Now that peak happening at the mean mu, we still have our standard deviation that we can keep track of, okay, off to the side. But now this axis we can represent for our different actual x values, right? And so when we start to calculate our probabilities then, right, find that probability that our x is less than some value a, for instance, right? We can find our value a on the number line, whether it be below the mean or even above the mean, right? But now that inequality, that statement, trying to find this probability that the value we pick, this value from our population is smaller than this value a, right? We're looking at that area under the curve. And that area on the curve, that corresponds to our probability. And that's the key idea that we're starting to implement with our normal distribution. Instead of having to calculate, right, that getting a value of an entire group, now we can start to associate these areas similar to, okay, getting one of these values that are in this region, all these different possible results, smaller than a, was a probability, the likelihood of getting one of those values out of our entire population. Okay, and with our normal distribution, the standard normal distribution, we have that common set of characteristics that our peak, the highest point, occurs above the mean, mu. We're symmetric about the mean. We have an equal amount of area to the left, to the right, equal number of data values above and below, right? And then the total area underneath that curve is equal to 1, right? So we have 50% of the area to the left, 50% to the right. In total, right, all the possible outcomes for that problem, okay? And so we're going to start to use StatCrunch to compute these areas, these probabilities, okay? And so in StatCrunch, and we'll get into this as we start to go through, for that calculation, we're going to go to Stat, Calculators, and then we're going to look for our normal distribution calculator, okay? And so we'll go through that with some of the examples. And so now moving forward, looking at some of this information, right, we're going to start to see these little bit longer word problems, right, start to organize our information so that we have values that we can then use to compute, all right? So looking at this first example in Monterey County, a single family home produces an average of 55 pounds of trash each week, okay? So again, I kind of made up some of this data, but you can imagine going through, right, some public records, going through some bigger data sets and identifying this information. But as we start to read through, right, when we see that word average, this is like our mean. And so in this case, the same for Monterey County, that single family home produces on average of 55 pounds of trash. So there's our value for mu, that 55 pounds of trash. Assuming that the amounts of trash produced by these single family homes are normally distributed, that's going to allow us to use our normal distribution calculator with a standard deviation of 6.8 pounds. So there's our sigma, 6.8 pounds, right? That variation, we know not every family is going to produce that same amount. There's going to be some variation, and our standard deviation is 6.8 pounds. So if we randomly select one family home, okay, find the probability that that single family home that we pick produces less than 45 pounds of trash, right? So in this case, if we're looking at this problem where this home is going to produce less than 45 pounds of trash, we're saying, okay, find this probability, right, that our X value, the amount of trash this single family home produces, is going to be less than 45 pounds, right? So less than that 45 pounds of trash. And so as we start to think about this problem, I encourage you to draw a picture. We have our normal distribution here, right? Assuming that all this amounts of trash are normally distributed. Here's our values for X. The mean, the average, the mu was 45 pounds. Keeping track, right? My standard deviation was 6.8 pounds, right? Now we want to find the probability that the amount of trash we pick, our X value, is going to be less than 45. Oh, sorry, my mean was 55 pounds. My apologies. There we go. Clean that up. But now we want to be less than 45 pounds. So again, we can scale later, but kind of get an idea. 55 is in the middle, our number line, right, from smaller values to greater values. 45 is going to be on the left side. I'll generically place it right about here. There's my 45 pounds. And we want to be less than that amount. So we're looking at all these values to the left, and that's the area we're looking for. So on our StatCrunch calculations, right? So let me switch this over. I'm going to share that StatCrunch. So in StatCrunch, we're going to go to Stat. Okay, we can see that Stat Calculators. And now we're going down to Normal Calculator here. Clicking on that. Now we see our normal distribution calculator. Right, we have that bell-shaped curve, that normal distribution. We have the setup standard when we have, less than, or we can switch this to greater than, right? If we are between two values, right, what's the probability that we're going to be between? We'll see that in the next example. We can click up here to switch, okay? But on that normal calculator, we're going to input our mean. So it starts off with a standard normal, the mean 0, standard deviation 1. But of course, that's not so common. So if we start to input our mean, 55, our standard deviation, 6.8, okay? Watching the decimals, watching the values. Now we can start to input from our problem. Remember, we wanted the probability that our x value was less than, whether we have less than or equal to or less than strictly, it's not going to make a difference with our idea. Getting one exact value isn't going to make a change. So less than or equal to is fine. And we want to be less than 45 pounds of trash. So once I put those values in, there's my mean, standard deviation. And again, that's where on our papers, we're going to make sure we identify what we're typing in. And now we're going to compute. And there's our diagram. So kind of matching up to the picture we had on the handout on that paper I presented, right? That area here that I color in purple, there's that area, that probability, and we have our decimal value like so, okay? And so I'm going to switch back to our paper. We'll copy that over. And so now from our StatCrunch calculation, we saw this probability, okay? So here, StatCrunch, right? I have my mean and standard deviation labeled. I'll kind of rewrite them here just so we don't forget. And we had that probability that x was less than or equal to 45, right? That's what we typed in. So now on StatCrunch, that result turned out to be 0.07070125. Okay, so there's my long unrounded decimal. For probabilities, we're going to round to 4 decimal places. 1, 2, 3, 4. That 0 says that 7 can stay the same. So my rounded result, 0.0707. So there's our probability, right? Like a 7% chance of that occurring, or 7%, moving that decimal place 2 places over for the percent. 7% of those homes are producing less than 45 pounds of trash each week, okay? And so again, going to our normal distribution calculator, we're able to get those values on StatCrunch, right? And on that StatCrunch is going to the stat menu, calculators, and then the normal calculator from there, right? Finding my long unrounded decimal result, rounding to 4 decimal places as will be our practice. So now this next problem, dealing with that same population, that same group. What's the probability now that if we select one family at single family home at random, what's the probability? Find the probability that that single family home produces between 50 and 60 pounds of trash a week, okay? So now we're going to be between those values, right? So we're going to say, okay, this probability that our x value is between, right? So it's going to be greater than, or we can do greater than or equal to, that's fine. Less than or equal to. On one side, right, we have 50, right? So 50 pounds or more up to 60 pounds of trash. And so then in that image, just to kind of get that graphic, get that visualization, so that way also when we're calculating and using that normal distribution calculator, the value makes sense, right? It kind of mirrors what we're anticipating here. Our mean 55 still the same. Our standard deviation is still 6.8. But now, right, with our values 50 and 60, we're kind of on either side of that peak, that mean. And now I'm looking for this area between those amounts. Okay? Anyway, we can use solid lines if you wish. Like so. And so on StatCrunch, doing that work, Now we're between, okay? The mean is still 55. Standard deviation, 6.8. But now our probability, we're going to see that we're dealing with our x between 50 and 60. Okay? And so then let's jump over to that StatCrunch screen. Here is our last problem coming up. Okay? So here's our last problem. Now, I want to be between mean 55, standard deviation 68. We want to be between 50 and 60 pounds of trash, right? Computing there. There's our long decimal. There's that area, that region we would anticipate seeing, mimicking that picture on our paper, right? So now we're between 50-pound trash and 60 pounds of trash, keeping that same mean standard deviation. All right, so now I'm going to go back over to our camera, the paper. We'll copy that, okay. Here we are. And so from StatCrunch, the long decimal result there, like I mentioned, 0.53783,961. Okay. I think I copied down all those digits, rounding to 4 decimal places, 1, 2, 3, 4, that 8. Looking next door on the right, that 3. Again, 4 or below, we're going to let that digit stay the same. So this is going to be 0.5378. Okay. So about 53.78%, almost 54% of those single family homes in Monterey County produce between 50 to 60 pounds of trash each week. Okay. And then finally, this question kind of, would I find it unusual for a single home to produce just to only 15 pounds of trash a week? Right. And again, we can kind of think about that number line with that number of standard deviations, right? But what we're kind of referring to in this problem, for something to be unusual, right? Unusual, we're using this characterization that the probability for that event, okay, is less than 0.05. We're going to use that kind of customary boundary value. So any probability smaller than that 0.05, smaller than 5%, is going to be unusual, right? And that kind of mimics that case of being more than 2 standard deviations below or above the mean. Okay? And so in this case, to produce just or maybe at most 15 pounds of trash, okay? Let me say here at most, right? We're looking at the case where in our diagram, we can start off with that even. We know that the average, the mean amount of trash produced is 55 pounds with a standard deviation of 6.8, right? But now if we're down here and say, what if they only produce 15 pounds of trash? So we're looking at what's the probability, the chance that we're going to get a household in this region with so far less than that average, right? Is that unusual? Is it really far down or is it not too bad, right? And so if I start to look at that probability that our X value is less than, or we can do less than or equal to that 15, right? And again, with StatCrunch, that stat calculator and the normal, right? With the mean being 55, standard deviation still 6.8. Looking at that probability that your X is less than or equal to 15, let's see what we get there. So with those values, sharing over again. Now we have that StatCrunch showing up, okay? Looking at this, we're not going to be between, we're going to standard deviation. Now we're going to jump this down to 15. 55 for the mean, 6.8 for the standard deviation. Calculating with 15. Now, in this case, it gives us this kind of strange notation, 2.0224 e to the negative 9, right? And this e negative 9, this is really the scientific notation. This is times 10 to the negative 9. So that means we're going to move that decimal 9 places to the, and a negative, right? So we're going to go to the left. So in this case, if I was to take that decimal point here, I'm sorry, let me switch over. I have to do that. There we go. Right, so now copying that notation, that e negative 9, that's our scientific notation, times 10 to the negative 9. That tells us to move the decimal 9 places over to the left. So this decimal is going to become extremely tough. Now we're going to have like 8 zeros in front of that 2. So this is going to be approximately 0 when we calculate. So definitely with that small decimal, right? We might not get something this tiny. Maybe we'll get like 0.002 in other examples if I had chosen like, say, 25 pounds or something like that, right? But getting such a small probability, definitely smaller than 0.05, our conclusion, yes, this is unusual. Okay? Meaning the probability less than 0.05, for sure it'd be very strange for us to get a result, this home that produces less than 15 pounds of trash. Not impossible per se, right? There's always that group, that possibility of getting one person that does that. But in general, for our population, that would be unusual. All right. So then as we go forward, right, we can definitely use that normal distribution to find those probabilities, right? And again, we could have also looked for being greater than 45 pounds, right? At least a certain amount, so on. And we could have switched that inequality symbol to the other direction, okay? And we can show that, for instance, let me do that calculation here. Right? So just as we're looking at it, if I want to find the probability that we're greater than, bigger than this amount, to change that direction, so they're reading that word in the problem, if we want to find the probability that we're greater than, say, right, that this family home produces more than, let's say, 72 pounds of trash, right? We can compute. We can get this small decimal, again, pretty unusual there. Or even if it's more than 45 pounds, suppose we did the wrong inequality symbol. For that first example we had done, computing, right? Notice how my picture, I got the opposite side highlighted, shaded. That area on this side, 0.929, that big probability, right? So that's where I start to use, right, shading your picture, drawing that normal distribution curve so that it syncs up with the values that we anticipate further. Again, changing that direction, you click on the inequality symbol, whether you want to be less than or greater than, notice it changes those calculations. And if we ever have a different mean, derivation, we can change those as well. Okay? All right. So getting back to another use of that normal distribution calculator, kind of going in the reverse of what information we have, looking at this next example. Okay? So as a requirement to graduate from high school, students must take an exit exam. To pass this exit exam, students must score at least 750 points. The scores on the exit exam at a local school are normally distributed with an average score of 812 points with a standard deviation of 47 points. If those students with the lowest 5% of scores must enroll a special summer school session to pass the exit exam, what is the cutoff score a student must earn if they do not wish to enroll in a summer school session? Okay? And so in this case, looking at that case, looking at these exit exam scores that are normally distributed. So we have this normal distribution curve. Okay. Where here's our exam score. for that x-axis, okay? The mean, the average exam score is 812 points. So there's our mean, our average, 812 points on that exam, right? So on average, they're passing because they need to get at least 750, okay, which is good. The standard deviation, assuming for our population of students, right? Sigma, 47 points. And so now, if those students with the lowest score, so these are exam scores, higher to the right, bigger values to the right, lower values to the left. These scores in the lowest 5%, right? Other times, maybe if you have the highest 5%, you're going to get a scholarship or what it might be, okay? You get some award, whatever it might be. But the lowest 5%. So in this case, we're saying, okay, down here, this is the lower scores. That 5%, this area of 0.05 is in this left tail, the lower values. And anybody with a score in this region is going to have to take that special summer school session, right? So our question is, well, what is this X value? What is that exam score? This is our cutoff value for that amount of area, right? So in some respect, we're wondering that if our X value is less than or equal to some value, okay, what that amount is, right? But that area, that 5%, 0.05, right? So we're trying to find that cutoff value, that X value, to give us this amount of area. We know the area, that lower 5%, we could have done upper 5%, the middle 50%, whatever it might be, okay? Reading that problem, the lowest 5%, lower values to the left, right? So we have the area of 5%, 0.05. What is that cutoff value going to be? So again, on StatCrunch, we're going to identify, we know the mean, we know the standard deviation. This time we have the area. So let's see what that looks like on StatCrunch using that same normal distribution calculator, right? And again, we can go back to it. I'll close this out for a second, but stat calculators, normal. Expand that view so we can see a little better. Our mean, 812 for that score. The standard deviation, 47. This time though, I'm going to leave that X less than, we want the less than, right? Because we want to be the lower side, blank. But now we know the area, 0.05. That 5%, always as a decimal in our work here. So that 5% converting to a decimal, 0.05, with the decimal place 2 places to the right. And now we compute, and it's going to give us this cutoff score, this cutoff value, that X value. This is the X value. That's going to make that area equal to 5%. Okay? So with our information, 812 for the mean, standard deviation 47. Once more, if I get rid of this amount, okay, get rid of that area, mean 812, 47 for the standard deviation. Now, if we know the mean has to be greater than 0, 0.05, there's that area, that 5%, the lowest 5. Computing is going to give us that X value. All right, so let me go back to our paper. And now here on StatCrunch, right, that probability that we're going to be given this area of 0.05 at 5%, our X value, 734.69188. In this case, if we're going to round our final answer, to the nearest whole number, right? So basically no decimals. So the ones place, that's 6, rounds us up. So our exam score, that cutoff value, 735, right? That 4 in the ones place, we're going to round up. So these students that do not want to take that summer school session, right? They need to score higher than 735. Otherwise, right? If they don't pass, they don't get that 750. If they get below 735, they're going to have to take that summer school session to make sure that they can pass that exit exam on their next try. Okay? But in this work, if we know the area and we're looking for this cutoff value in StatCrunch, we're going to leave that quantity blank, keep track of which side we want, whether we want the left side. If it's on the right side, we switch that over to the greater than, and you input your area, that given percent, as a decimal number, and that'll produce our cutoff value. So we know the area, trying to find that cutoff value, we leave that part blank, we still have our mean, standard deviation, the unrounded decimal solution. In this case, if we're rounding that exam score to the nearest whole number, we can do some other problems. We might be rounding for like money, we round to 2 decimal places, so on. Just watch out for those directions. Okay, so there's that use of our standard normal distribution, that normal distribution calculator on StatCrunch, in order to evaluate and find these different probabilities, these areas under our curve. All right, y'all.